Welcome to part 4 of our series where we cover the Quadric Chimera GPNPU. In our previous briefings, we covered more of the individualistic blocks, anywhere from the core architecture that underpins the individual compute units, all the way to the software framework that underpins the architecture. However, we're going to take a more macroscopic approach today where we look at the scalability of the Chimera GPNPU family and really see if it is truly scalable or maybe it hits certain roadblocks as it takes discrete steps up in compute capability. The Quadric Chimera GPNPU product family fits into four discrete buckets: the Nano, the Perform, the Ultra, and the Multi. But before we dive into the individual buckets that Quadric has set for the market, I truly believe that the architecture could be more linear with its scaling, where it doesn't necessarily need to take discrete steps up, but this is more for customers to self-identify. Starting with the QC Nano, or the Quadric Chimera Nano, if you will, it ranges from 1 to 7 tops, and this is best fit for what I would argue would be your earbuds or maybe your AI IoT market. And let me put a pause in here and let everybody know that I understand that tops, or trillions of operations per second, doesn't necessarily tell you much. There's a lot more that goes into actual AI performance, such as the data movement, such as the fabric, such as the power network. And while TOPS is very much a theoretical marker, it's basically the theoretical marker that a lot of these IP vendors use to compare apples to apples. Now, with that digression, let's move to the next product family, which is the QC Perform, or sorry, next product offering or bucket, if you will, which is the QC Perform. This one scales from 4 to 28 tops, and this is where you start to get into your entry standalone AI market. So it'll be set for things that are focused on computer vision or maybe industrial IoT, where it's not going to necessarily be the heftiest AI workloads, but it'll be beefy enough that where you may not want to run it on a CPU and use a discrete AI accelerator for power and performance reasons. Now, taking the step up to the QC Ultra, this one ranges from 16 to 108 tops, where you might get the broadest range of applications. You may have small, large language models, which may sound oxymoronic, or maybe agent-based large language models that perform specific tasks. You could have anything from level 2 to level 3 ADAS applications, including sensor fusion or video fusion and in-cabin monitoring. And from a theoretical performance standpoint, anywhere from 16 to 108 tops would more or less get you there. And then finally, you're going to have the QC Multi, where it seems like they take maybe a combination of the QC Perform and QC Ultra and start to tile this to reach up to 864 tops, or 256,000 Mac units plus 8,000 ALUs. Now, at this point, you could be looking at applications where you might be inferencing for the data center, or you might be looking at applications where you might be inferencing on your PC or maybe your smartphone for truly large language models or potentially vision transformers. The real question that I guess we have to answer is the Chimera GP NPU truly scalable? And I guess before we go into answering that question, we should probably ask a broader question on why does it matter? A lot of these AI IP startups, whether it's Expedera or Quadric in this example, or even some of the bigger companies like Siva or Cadence, the holy grail is to build a piece of IP, a singular architecture that is scalable from the lowest end into the most compute intensive workloads, such as LLMs. And if you can truly do that, then it mitigates your R&D or architecture dollars spent in designing the product. That being said, it's obviously easier said than done because as you start to see with a variety of products, as you scale up from, let's say, a super small SoC with a very tiny Chimera offering, such as something in the nanospace, all the way to a reticle-sized die or maybe even chiplets, and you get the multi-instance variety of the Quadric Chimera GPNPU, you run into SoC integration issues. So while the architecture itself may be theoretically sound, you may be getting issues such as how do I deliver enough power to the IP, to the right places in the IP? Are there voltage droop or voltage fluctuation issues that I need to deal with? Do I need to place multiple clocks to control timing at a more granular level, or do I need a single clock? What are the jitter requirements across the chip? Is it consistent? And finally, how does my IP or how does this Quadric IP interface with my SoC? Are the between the nano versus the multi-instance, is there a wide enough bus that data will flow freely and not get bottlenecked at the network on chip or ring, whatever architecture interface? So that's kind of issue one that you start to see with potential scalability for some of these AI IP. Potential issue two is the software. Do you have a consistent software that again scales from your smallest offering to your largest offering? Does it take into account the physicality of workloads where you don't want to necessarily place workloads that are split between a core on the top right side of your IP and a core on your top left side of your IP, because then there will be increased latency. And on top of that, how do you make sure that all your workloads fit into the thermal management system that your integrator might use? And then finally, and this is more controllable by the IP provider, is how scalable is the interconnect fabric between your Mac units and your ALUs? Is it actually going to be able to efficiently scale from, again, the nano offering for Quadric all the way to the multi-instance? Is what changes are needed in the data fabric such that you can have reliable and almost deterministic computing regardless of what offering you're getting? So with these points, it does bring us back to the question, is the Quadric Chimera scalable? Now, from what I've seen on preliminary benchmarks and discussions with other folks, it looks like it could potentially be scalable, but the proof will really be in the pudding. As the Chimera GPNPU starts to reach SoCs at different compute points, we'll see if the throughput, or the AI throughput, scales. And part of this, it's not going to be an apples to apples comparison because there will also be considerations like how is the rest of the SoC built. So this concept of is it scalable? In theory, yes. In practice, that's a little bit of a harder question to answer. In recap, we covered the entire product family of the Chimera GPN, Quadric's Chimera GPNPU, in addition to asking some of the harder questions of the true scalability of the product family. And in our final session, we're gonna put the Chimera GPNPU in a qualitative head-to-head to some of the other AI IP offerings. While I haven't exactly decided which ones I'll be comparing it to, I plan on looking at some more established offerings, such as what you may see from a Siva or a Synopsys or Cadence, and against some other startups in the field, such as Expedera. That being said, thank you for listening to me and my ramblings on the Quadric Chimera GPNPU. And I never thought I'd be saying this, but please like and subscribe or drop a comment on what you want to see next. and I hope to potentially grow this channel. And I thank you for coming along with me on the ride.